So this is just an hour, and this is kind of a really basic intro to what is GIS. If you're just kind of curious, you've heard this phrase, or maybe you're thinking about incorporating GIS into a project. I'm Megan Slimmons. I am a research library fellow with the Emory Center for Digital Scholarship, aka librarian. And this is Jennifer Doty. She's our data management librarian, and she's going to help out when we do the exercise, just kind of float around and help everyone keep up with what step we're on. So feel free to email me if you have any questions after the class. I put my email on the handout. And let's just go ahead and get started. One second. Okay, now it's working. Okay, so what does GIS mean? So it stands for Geographic Information Systems, or sometimes you'll hear science for the S, but systems in general. So geographic means we're talking about the study of the Earth, just to kind of break down what all the parts mean. Information is any sort of data, facts, knowledge that you have. And then systems is the computer, software, and hardware that allow us to kind of bring these two together. So GIS is basically a system that links statistical data to maps, or I've heard it just said databases linked to maps is kind of a good way to think about it. And it allows you to analyze and relate data based on a common geographic location. That's kind of the essence of what GIS does. So here's a nice visual to kind of make it really simple. We have a table of data and a map, and we can bring them together and display the data spatially. That's actually a map of the UNC Chapel Hill campus with the older buildings are the red colors and the blue buildings are the newer buildings. So you can kind of see how the campus has spread out. That's just an example of something that you could do. So what can we do with GIS? I'm just going to kind of scroll these up and not read to you, but these are just some examples of ways that GIS could be applied to all sorts of disciplines. It can be applied to pretty much anything. Got a few of these up here. Okay, so that's kind of some ideas. So GIS allows us to create thematic maps. This is one of the most common things that you can do. One of the most common things that you can do with GIS. As compared to something, a reference map may be what you're more familiar with, like a road map or a map of hiking trails, something like that, where it just kind of displays a bunch of features for the purposes of looking up where they are related to each other. It's not trying to emphasize any one over another. So a thematic map aims to visualize data, and it focuses on a specific theme. One really cool thing is that you can convey quantitative information, which is what a lot of people are trying to do with GIS. So I have a couple of examples up here. This is a map just from the Census Bureau, and it's just counties in the U.S. where the darker counties are higher population density. So that's just an example of something you would do. We're not really using this map to see where states are in the country. We're looking at a particular theme, so that would be a thematic map. And this one I think is really neat. This is kind of one of the earliest examples of thematic mapping. It was created by a London physician named John Snow in 1854, and there was a cholera outbreak going on right then. And all the little bars that you see, the little blocks kind of sticking up next to the streets, are instances of cholera mortality. And so what he did was he was able to locate the contaminated water pump that was causing this, and as soon as they shut it down, they had like an almost instant cease in new cholera cases. So it's kind of the power of thematic mapping. Okay, so what is geospatial data? This is a term you're going to be hearing as you work with GIS. Basically, data that's tied to a particular location on the Earth's surface. Sometimes you'll hear it just called spatial data too. And this is the data that we can access and manipulate with GIS. And location is a critical aspect of the data as compared to if you had like a list of employees and you had their address information just because you were going to mail stuff out to them. That's not really, the location isn't a critical aspect. It's just kind of information. But if you were going to want to actually map where everybody lived because you're trying to move to a new office building that's kind of centrally located, that would be an example of, where location is a key aspect of that data. But any data that has location as an attribute can be mapped. So there are kind of two major categories of geospatial data. You probably have run across these terms in some format before, but vector data is basically shapes with like concrete boundaries. They come in 3 types, which is points, lines, and polygons. And all of them are basically points, but a line is just 2 points connected versus multiple points connected for a polygon. And then raster data is more continuous data, stuff that doesn't have concrete boundaries. Images are probably the most common example that you'll think of, but also things like temperature maps or precipitation, where you kind of see the gradual shaded changes. Okay. So vector versus raster, just to go into this a little bit more, it's good vocabulary to have. You may have run into these terms before, like if you use Adobe Photoshop and Illustrator. Photoshop's more for raster data and Illustrator's more for vector images. But the difference is vector data, if we were to zoom in on this line, it's just 2 points that are connected by a line, and that's all that the computer is actually storing. So what that means is that it can be scaled to any size without getting pixelated, which is kind of neat. And then by comparison, if we were to zoom in on the same line as a raster image, it's actually just a grid, and each cell is assigned a certain value. And so it's just like when you zoomed in on a picture too far and it gets all pixelated, they're not really scalable. But they just display different kinds of data, basically. We're going to look at a few examples. Some examples of vector data, these are going to be things with like XY coordinates and discrete boundaries. So these are just some kind of real world examples. Some point data would be like target locations in Atlanta. Lines, this is the metro in DC. And then polygons, these are different ecoregions in Georgia, or it could be something like counties or school districts, anything with a definite concrete boundary. And then raster data, again, is going to be more continuous data like elevation, images, temperature, that doesn't have discrete boundaries. So this is satellite imagery, like just imagery taken from space. Aerial photography is taken from planes. Scanned maps, if you were perhaps working with historic maps and you had scanned the image in, you could work with that in GIS. And then this is a soil map, just to give another kind of idea of data that doesn't have concrete boundaries. Okay, so layers are kind of the key feature of GIS. This is where all the power of the tool is. It allows you to compare data based on a common location. You have your geography, your just regular old map on the bottom, but then you can layer up the data based on that same location. If you were looking to do something like open a new store and you needed data about where customers live, what the spending is in the area, where competitors are located, you would be able to look at all of that and decide, an ideal location around the area you're concentrating on. So another vocab word that you're going to run into is attributes. This is the database, basically, that's linked to our map. And this is how we do our thematic mapping. It's the characteristics of the features just stored in a regular tabular data format. So our data, we can manipulate the data based on these attributes, and we can also use it to label and symbolize our features. Symbolizing would be like when we shaded the counties based on their population density, or we could use it to label various features as well. So some technical things that you'll have to think about when you start working with GIS software. These are just some words that you're going to hear, and it's good to kind of understand what they mean. I'll just go ahead and put those up there. But coordinate systems, projections, and scale. Coordinate systems basically deal with the fact that the Earth isn't actually perfectly round. It's kind of lumpy. And so there are different approximations of the Earth's surface depending on which section of the world you're actually going to be working with that'll most closely match up. Projections deal with, the Earth is a globe, but sometimes we need to print it on a flat map. And so how do we transform it? It's like trying to unpeel an orange and lay out the peel flat, basically. What do we do to make it display on a flat surface? And then scale is just the relationship of the size of things on the map versus the size in the real world. And again, that'll kind of depend on the goal of the map that you're going to make, whether you want to be zoomed in really close or if you want, the whole world on your map. And a lot of this kind of deals, ensures that your data matches up properly. Sometimes you may have a problem where you're mapping things and they're supposed to be in the same area, but the points are next to each other. It may be something with your coordinate systems or your projections especially not matching up. So just to look into that a little bit more, coordinate systems is...
So what is the relationship between the projection and the coordinate system? Like,
well,
is it like because we have to work with three-dimensional data, or it's just like infinite two-dimensional data?
Right, so what can happen sometimes is you'll have data that you bring into your GIS that is in two different coordinate systems, and maybe you don't even realize it at first. And so that can actually make it not line up. And the same thing can happen with projections too. It's a good thing to check for if you're having some sort of a data mismatch. It's one of the most common problems. So coordinate systems is basically just the grid, the intersecting lines that are used to define points on the Earth's surface. And that can be either geographic coordinate systems is like your latitude, longitude, when we're dealing with the round Earth. And then your projected coordinate system is the one if you're putting it on an actual paper map, and we just have regular XY coordinates. So then projections. I think this is a really neat image to look at. It just kind of helps you visualize that a lot of projections can be thought of as kind of having a light bulb in the middle of the Earth and shining it out onto various different shapes. And they all have advantages, but there's basically cylindrical projections, conical projections, and planar projections, and they're kind of different. They're accurate for different areas of the world. Some projections kind of minimize distortion everywhere. They compromise a little bit on everything so that the whole world looks kind of like what you think it should. And then some of them are very accurate for even a very tiny area, just for a country or just even for a section of a country, and the distortion's really huge when you go out from there. So it depends on, the size of the area that you're working with. But all projections do distort at least two of those things: shape, area, distance, and direction. Shape is the actual kind of angles of the outside, lines of a country, for example. And then area is the size, distance would be the measurement between 2 points, and direction would be the actual angular measure on a compass if you're traveling from one place to another. So you can't ever have a projection that keeps all of those things straight because, again, we're taking a round map and putting it on a flat piece of paper. Okay, so map scale. I think this is kind of hard to keep straight in your head because the terminology is kind of opposite sometimes, so I just wrote out a bunch of different ways to think about it. Again, we're just talking about the size of things on your map versus their size in the real world. So small scale covers a larger area. This would be like a world map or maybe a map of an entire country. Opposite for large scale, that would be like maybe if we were just mapping our campus or something. So small scale shows less detail because, again, we're looking at a big area. And then also scale is represented as a ratio. So I just put up examples of a small versus a large scale ratio. Any way that you can get it to think it's kind of hard. Small scale has a big number on the right. It's a little bit backwards, but it'll stick eventually. And then just some advantages of each. Small scale is good for finding location relative to other points. For example, if you're traveling from one city to another maybe and needed a bigger map of several states versus a large scale map, maybe if you were trying to find a building on campus, you would need something zoomed in pretty close because you're trying to figure out where the walking trails are. So here's an example. There's Savannah on a small scale map, and there's Savannah on a large scale map. Can anybody think of any advantages to each one or notice any major differences?
I guess the small scale would just, you'd be able to get information in Savannah relative to other things, but nothing inside of that.
Right. So like if you were trying to get there from Atlanta, that would be really handy if you didn't know which direction to head. Versus, I mean, kind of the main difference that you see with the large scale is the really detailed view of all the waterways if you were studying like coastal ecology or if you were driving a boat and didn't know where to go with it. So when you look at it on the small scale map, it just kind of looks like a straight little coastline because there's not much detail there. Okay. So we talked about using geospatial data. You can use data that already exists, but there are also several ways to create your own data. First, you can import tabular data and join it with a map. The main thing to remember is that the data has to have some sort of location as an attribute. We can also import GPS data. If you actually went out in the field and collected data with a GPS unit, you can actually check these out upstairs in the Music and Media Library if you ever need them for a project. And it's a little bit difficult to get GPS data into GIS software. It's not as compatible as you would think, but there are tools out there that can convert the points into something that you can use.
So question,
Yeah.
When I import, let's say in the first case,
Sure.
so do I need to necessarily use a database, or it's just
It could be like an Excel spreadsheet of information you have.
How do I go to location information? Let's say shape of the polygons kind of stuff.
Where would you get that from? Is that what you said? Sorry.
If I have such a data,
Mm-hmm.
so you said import tabular data and join it. So you're talking about specific tools, or it's just in general?
Well, in general, you could do that. There are data sources where you can get the actual, what's called the boundary files if you need the outlines of your counties or your states or whatever. And then you could bring in your own data that was just in an Excel file and join it up. And you would join it based on something like a FIPS code if you had it especially joined really well. Or there are ways, if all you have is addresses, that might actually be my next point. Yeah, there are tools to geocode addresses, which basically takes just a regular street address. You don't have latitude, longitude coordinates or anything, but it can actually take these addresses and turn them into specific latitude, longitude coordinates so that they can be used in GIS.
What about the GPS data? Is that what format is? Is that WPT or is something different?
The GPS data, it can be made compatible with GIS. There are some tools, there's one called GPS Babel that you can put in your actual coordinates that you got out of the GPS unit, and it'll convert them into a format that'll work with the GIS. So it's a little bit tedious to get it in there, but you can definitely do that too. Yeah.
How long can you check out one of those GPS units for?
I'm not sure. I can look it up and get back to you on that, but I do know they check them out. Sorry about that. And then the last thing we can do, I mentioned this earlier, you can georeference images. If you perhaps scanned in a historic map and you wanted to actually be able to analyze it with GIS software, there are ways to actually look for known coordinates on the map. We know where this building is and we know its latitude, longitude, and it's still in the same place. We can use that as a reference point to kind of locate things around it. So there are ways to work with something that predates computer software. So just a note about documentation, that's a really good thing to keep in mind. I know it seems kind of whatever, but when you first start a project, it's really important to keep notes of where all your data come from, because it can get really overwhelming after a while. And also any transformations, calculations that you make on it. The point is that somebody would be able to replicate your study at the end. So just a note, keep good notes along the way. And it's also important to attribute your data and everything just like you would when you're writing a paper. So there are lots of GIS tools and software out there. You guys may have heard of ArcGIS. That's kind of the big GIS software. It costs a ton of money, and it's by a big company called Esri that kind of controls the GIS software market. But there are some other options out there. There's both desktop options and web-based options, and then I group them into free and not free. Even though the not free ones are free to you guys, as long as you're affiliated with Emory, you can use them. The desktop options in general have a steeper learning curve. ArcGIS is pretty complicated software. It's not something you could sit down and learn in a week to do a project. But it definitely can be learned, and we have a lot of tools to help you do that. And then a lot of the web-based ones originally were kind of more like geospatial viewers. You could kind of look at data and interact with it, but not really do any calculations. But a lot of them are actually moving a lot more towards analysis. We're going to play around with ArcGIS Explorer Online today, which is made by the same people that do ArcGIS, but it's a web-based kind of GIS Lite version, which a lot of times is all you really need for your project. Sometimes you don't have to dig into the really complicated software. There's also QGIS, which is kind of the main competitor to ArcGIS. It's an open source, free desktop ArcGIS software. That was a lot of things to say. And one cool thing about that is it works on a Mac. ArcGIS is Windows only, so QGIS is free, and it's Mac or Windows. So, okay. Oh, and one other thing I wanted to say. Yeah, sure.
So you said the ArcGIS and Google Earth for it. So do they necessarily do the same thing, or like they have separate purposes?
They don't necessarily do the same thing. A lot of them do have overlap, but yeah, there are definitely different strengths with all of them. A lot of this stuff and some other specialized software, we have a new thing called Global Mapper that I'm not that familiar with, but we have a lot of the software available in the Emory Center for Digital Scholarship, which is right down the hall, the big glass room. And it's also available in some other places on campus too.
If you make a map in the Quantum GIS, would it open in ArcGIS for someone else to look at? Like what overlap is there?
I have not used Quantum GIS that much, so I'm not positive of the answer to that. I'm kind of leaning towards not really. A lot of the time, GIS software, if it's saved in one of those formats, is not really accessible unless somebody has the software on the other end. But there are a lot of other options for publishing it in a format, something like Google Earth, where maybe they could view it in a browser after you've done all the actual work. There's a tool called GeoPDF. I don't think I have that up there. That actually outputs a PDF document that anybody could open. You have to download a plugin, but it can actually be pretty interactive. If you do all the work in the complicated software, there are ways to get it out to people where they don't have to have the software on the other end to view it.
So is the shape files not like compatible? I thought that's the standard.
It would be a shape file, but I don't know that the whole thing would necessarily just open up that easily. You may be able to kind of reassemble it. I don't have a great answer for that one. Okay, so now we're going to do this exercise that you guys have a handout about. This is just to kind of get a little bit of GIS experience. And again, this is one of the web-based tools. So it's not as complicated. We can kind of make a map in probably like 20 minutes. So we're going to investigate this question. Do the areas around universities have younger populations? And this is just using lots of freely available data, and it's pretty quick. And we're just looking at the University System of Georgia because that was available in Wikipedia. Okay, so everybody can just open a web browser, and we're just going to kind of go through the steps on this handout together. And if anybody needs, if you have a question or anything, just stick your hand up.
Sorry.
Yes.
Mac or Windows?
You can do either, since we're just using a web browser. It won't make a difference.
I mean, is there like usually a preference?
Not for something like this.
Yeah.
Nope. Just Chrome or whatever you prefer. And if you do have a question, Jen's available too.
Firefox is actually better for this.
I think I remember that. I had forgotten. Let's do Firefox.
Firefox?
Yeah. I think we did have some issues with Chrome last time on some of the computers. Okay, so as you're pulling that up, just go ahead and we're going to go to www.arcgis.com/explore. And so go ahead and click on the new map button that's in the top left there. Is everybody's working okay? Did the website come up? It has been known to crash before. Okay. Okay, so I know, right? I was trying to read an article on Eric yesterday, and they were like, sorry. Oops. Okay, so new map.
New map.
Everybody got a new map?
Yeah.
Okay. So the first thing I want to do is change the background to something a little less busy. There's a little button kind of on the top left that has 4 little squares, and it changes the base map. So I'm just going to change it to light gray canvas, which is kind of boring, but we're going to put other stuff on top of it. And the next thing I'm going to do is just kind of zoom into Georgia. You can actually, there's a little tool with a little magnifying glass and a rectangle where you can kind of draw.
What should I do?
Or you can just drag.
Oh, like brick canvas.
Light brick canvas. Okay, thank you so much.
Okay, does everybody see Georgia more or less?
Yeah.
So a tool like ArcGIS Explorer Online has some data freely available in it. So we're going to use that first. If you go up to the top next to where we change the base map, there's an Add Content button, and this is how we get any kind of data in there. So I'm going to click on that, and I'm just going to search age, because we need the age data for what we're looking at. Okay, and the first thing that should come up is US median age, and I'm just going to click the little add that's right on the bar with it.
Yeah, I hope my data would like that. That would be really
I know, right? This is already looking pretty legitimate. Okay, so the next thing we're going to do, this is the more tedious part. We're going to go get some University System of Georgia data from Google. So if everybody can just Google universities in Georgia. And the first, this is like really busy. The first real result should be with a Wikipedia article called List of Colleges and Universities. As Wikipedia does, it changed since I made these directions, so we're going to scroll down a little further. When I made it, there was no table of all the public and private universities. Now there is, so we're still going to use just the public ones so that the directions will work. So if we kind of scroll down a little ways, maybe about halfway, there's a table, there's a section called Public Institutions and a table called University System of Georgia. So what I want to do is copy that entire table. Whoa. And then you can go ahead and open Excel and just paste all the data in there. And it's going to look like kind of a mess right now, but we're going to do a little data cleanup because this is kind of a not fun part that you're going to have to do if you are collecting data and working with it. If anybody gets ahead a little bit, you can go ahead and start going through the data cleanup because some of it's just a little bit tedious. But I'm going to go through and just start deleting some of the columns we don't need. We just need the institution, the location, and the enrollment because we're going to use that a little bit later. Whoops. Whoops. Did somebody's computer freeze?
No, thanks. The camera just moved.
What?
It just shut up.
Oh, it did? Okay. Oh,
Weird.
yeah, I mean, that was like 5. That's crazy.
So for whoever's right here, I'm going to go ahead and delete this row that says total. That's something we don't need, like the third row down. I'm also going to fix the title for enrollment because it needs to be just one line. Whoops. Try not to click the hyperlinks while you're typing. everybody kind of close to there? Okay. So the next thing I want to do just to get rid of all the hyperlinks and all the kind of weird formatting is just copy all the data that I have, and then we're just going to go to the next empty column and paste special and just paste the values. And what that does is it loses all the formatting. So I'm going to copy, and then I'm just going to click in this next open column. And I'm going to do paste special. There's a bunch of ways to get to paste special. If you know a better one, that's fine. And I'm just going to click values and OK. And then I'm going to delete these first 3 columns that are kind of a mess. So this is starting to look a lot more reasonable. The next thing, if you're already caught up to here, if you want to start on this, you can go through on each of the universities where it has like former names and stuff in parentheses and just delete all of that, because ArcGIS Explorer doesn't recognize special characters like that, and so you're going to get all kinds of weird little asterisks in your names. So like here, I'm going to delete where it says Georgia Tech. This is not essential, though, if you're still trying to catch up on something else.
What should I, sorry,
Yeah.
when I do paste special, then what option do I choose?
Values.
Oh.
And that takes just the actual like letters and numbers and loses all the formatting.
And then I delete the rest of the
Just delete the original stuff. So data cleanup is not a lot of fun, but a lot of these software, even the web browser ones and the desktop ones, are real finicky about formatting on things. So this is something you'll get familiar with, having to go through and take all of the spaces out of your column headings and things like that can mess it up. So the next thing we want to do is the column that's called location. We want to change that to city because we also need to add the state in. And then go ahead and insert another column next to the city and type state, and we're just going to fill it in with Georgia for everything. And if you don't know this little trick already, if you just type Georgia in the first block, and if you hover right on the bottom right corner of the cell, you can drag it down and it'll copy it in the rest of them. Ta-da!
How do I add another cell?
Add another column, just right click before the one that you want to add it in front of and just insert.
Oh.
Did that work?
Entire. Oh. Thank you.
You're welcome.
Oh, it's in front of city. Yeah, that's okay.
That's okay?
Yeah, you can move it.
Yeah.
What state?
Okay, so if yours looks kind of like this, if you feel like you're about done with all your formatting, we want to make sure and save it as a CSV. That's the only type that that the program we're using will take. You can't save it as an Excel file. So we're just going to File, Save As, put it somewhere easy to get to, like the desktop. And I'm just going to call it USG for University System of Georgia. It doesn't like spaces in the title name, so keep that in mind. And then format is going to be, wherever it is, right here, comma separated values .csv.
I have like multiple CSV.
There should be one that's kind of the most regular.
Yeah, no,
How much
and
in
it
a minute?
just says how much
in a missed off?
Yes,
Yeah. Okay.
Is it the same Windows or MS GOS? Because Windows comma separated or MS?
The one at the top, yeah.
All the way
Right there.
Thank you so much.
Yeah, there are a lot of choices.
Yeah,
I'm not
don't
really
worry
sure what
about the
all of them
ones that
are.
tell you it's your operating
Okay.
system. You want the one that's just comma delimited or comma separated. Right?
I have like a thing saying USG.csv may contain features that are not compatible with CSV.
That's okay. Just say yeah.
Okay.
And every time,
So trying to be smart.
Okay.
yes. Oh, that's exciting. I don't have permission to save to the desktop on this computer. Okay. Thank you.
It's a new thing this year.
Whoops.
I try to make sure people haven't saved data
Right.
to these computers.
Yeah.
You know, for that.
Okay. Save. That's good. Continue. And then once you've saved it, go ahead and close the file, and it's going to give you all kinds of error messages, but you don't need to save it again. Don't save. We already saved.
What is it called? You have to call it something or just
USG.
USG.
Yeah, that's fine. Okay, so the next thing we want to do is get this data into our map that we're working on. There are actually several different ways to do it, but it all comes from this little Add Content button. There is actually also an option where you can line up your windows where you can see where you actually save the data to, and you can drag it right onto the map and it'll pop up, but it doesn't always work on a Mac, so I think maybe we just won't try that. But it's kind of fun if you ever want to play around with that. So add content, instead of searching like we did last time, we're going to add our own content. So we want to do import.
CSV.
Yeah, and CSV is going to be a choice. And here you actually have several choices. You can either browse for a file, which is kind of the normal thing. You can actually also just copy and paste the table in there and it'll take it, but we're just going to browse for a file. That's the most foolproof. And find where you saved your file. And you can see when it puts it in there that it actually does just separate your columns by commas. That's literally what it means, comma separated values. It's kind of nice to see it there though. So once that shows up, just go ahead and click Next. And you'll get this little import window. And you'll see, if you look down at the bottom, the data formats, it actually correctly recognized everything. That's not always the case, so it's a good idea to double check. But this recognized text, city, state, and just integer for the enrollment numbers. So I'm going to go ahead and say import.
So good.
All right, we got some data. Okay, so we can't see these pins very well. Let's do something to make them show up a little bit better. If you look over on the side, this little bar, this is kind of all of our menu options, and if you click the little right arrow, it'll pop it out. So the layers menu is kind of where we do all of our editing and stuff, and I'm going to go to USG, which is the data we just added, and click the little right arrow. Does everybody see that? Yeah. Okay, so then we want to configure the display. So I'm going to click that big button under display. And we're going to leave it at single symbol right now. We're just marking where everything is. But I want to change the current symbol. I'm going to pick this yellow stick pin just because it shows up a little better with the colors we have. And I'm going to change the size. You can either drag the little slider bar. Whoa, that's excessive. Or you can just type in. I'm going to change it to 50. It's kind of a good size. And then you can hit the back arrow and say done. So this is looking kind of like a real map. The last thing you need to do to kind of, if you were going to maybe print this out or save a screenshot of it, is we want to show the legend so people know what it's a map of. So if you look on the little tab sticking out from the menu, the very bottom one is the legend. And if you click on that, that'll show it. And then you can just kind of line everything up where this looks like a finished map product. And so, yes, we can kind of see that it looks like the younger populations kind of cluster around the universities. The younger populations being the red and the pink, you can kind of see around each of the stick pins. It's just an interesting way to look at the data. Yeah? Did you have a question?
No, I just said that's very interesting.
Oh, okay.
Yes.
Does everybody have something that looks kind of like this? Okay, so I have a little bonus thing on here that we can do now because we have plenty of time because I talk fast. Basically, we just want to go through and symbolize the universities by enrollment so we can see where the big ones are versus the small one if that has any impact on it. So what we want to do is go back into our layers menu, which is the top little tab on our menu there. And we want to click on USG again because we're going to do some more editing. And we're going to configure the display again. This time, instead of single symbol, if we do this little drop-down menu at the top, we want to classify using size. And we need to do a little work on this because the little tiny stick pins don't show up. So I'm going to go ahead and change the template symbol. And I'm just going to pick the very first circle that's an option there. And then if you want, you can also play around with the colors, something that shows up a little better. I think green shows up better.
How do I change?
Do what? Let me see.
No, I think I forgot how to go to the stick pin.
Oh. Click the little arrow there.
Oh,
Yeah, template symbol.
okay.
And then pick the first circle. And then you can play around with the color and the size. Outline. And then you can also, if you go back one more to the menu where we got the template symbol, down at the bottom you can play with these little slider bars and, maybe make your start size bigger and make the difference a little more exaggerated so everything shows up better. And you can also play around if you want with the classification method. It's set to equal interval right now, which means there's an equal break between each of our 5 classes. But there's lots of different ways to do it. Natural breaks just kind of looks for what it sounds like, the natural breaks in the data. And, there's a few other choices. But equal interval is usually a good one to just kind of stick with. And you can also change the number of classes, but again, 5 looks good. If we put too many in there, it'd be hard to tell the difference between the circle sizes, basically. So once we're happy with this, we can say done and go back to the layers menu home. And one final thing that is going to make our legend make a lot more sense, since they are classified by enrollment now, instead of it just saying USG, we want to change it where it says USG by enrollment. So down at the very bottom, there's this organize button, and it just lets you edit the layers, basically. So I'm just going to add by enrollment and say done, and then display my legend. So now that would make sense to anybody looking at this map. So now you all have GIS experience. And this is actually a pretty neat tool that a lot of times will be good enough if you just need to visualize something kind of quickly and don't need to do a lot of really complicated analysis. Okay, so I have like one more slide to talk about. So if you're interested in all of this and you think maybe you want to learn some more about GIS, these are just a few different resources we have. We do have a Blackboard course that's just got a lot of tutorials and training material in it, and you can just send me an email and I can enroll you in that. And it's just something you can look at freely on your own, just a self-paced thing. There's also the Esri Virtual Campus. Esri's that company that makes ArcGIS and also the thing we just used. And they have really great self-paced web-based training courses. They're not free, but we have a subscription through a campus-wide subscription. And so if you want to look through the course catalog and ask to be enrolled in anything, I can do that for you. And that's a really great way to kind of learn the software on your own. That's how I did it for the most part. We also have a few classes available that are kind of introductory GIS courses. These are all going on this semester, 1 in environmental science and 2 in public health. And then finally, I do walk-in GIS help hours on Mondays from 3 to 4 in the math and science reading room, and then on Fridays from 12 to 1 in the health sciences library. So feel free to drop by if you have any questions and talk to me.